Hello, Marauders. Welcome back. Whew, I'm getting wet here. Oh, this feels so good in the water. But today's our last day of stuff on radicals. Today we'll learn how to simplify the radicals if a radical's on the bottom. People don't like radicals on the bottom. They have an issue with it for some reason. They consider it bad. I'll tell you how to get rid of the radical on the bottom of a fraction. And we'll do some review of Pythagorean theorem and even sneak in a few other little surprises in there. And then tomorrow, Thursday, or Friday, if you like, you can take the test on Pythagorean theorem and radicals. Is there more to it? Yes, I would. If we were in class, we would spend a whole week on this and learn all types of other cool things about it and applications. But either way, we'll do what we can. That way next year in Math 2, you're like, cool, I know how to do this. Okay, one of the things we normally do every year is this connect the dot worksheet with radicals. It's a lot of fun, but it doesn't really work too well on here. So we'll miss out on that. But here's something. For some reason, okay, there is some reasons, people don't like radicals in the bottom. Like if I put 7 over radical 3, they consider, well, that's not allowed. They do not like to see a radical on the bottom, okay? This upsets them. After all, if they wanted to like add some fractions, like 1/2, you're like, well, I don't have common denominators. So they like to get rid of that. So how do we get rid of a radical on the bottom? It's quite a simple trick. 7 divided by radical 3. In fact, let me just see what the Casio says. 7 divided by radical 3. It says 7 times the root radical 3 over 3. It's called simplifying it. It doesn't look any simpler. To get rid of a radical on the bottom, you're going to multiply it by 1. Multiplying by 1 won't change it, but not any type of 1. Whatever you see on the bottom, choose the exact same radical and put it on the top, radical 3 and radical 3. So the top, 7 times root 3, I don't know. It's 7 times the square root of 3, which is some weird decimal, right? Radical 3. The bottom, square root of 3, square root of 3. What is square root of 3 times square root of 3? Square root of 3 times square root of 3 is square root of 9. The square root of 9 is 3. Or you can think of it as square root of 3, square root of 3. It's twice, so that's squared. And the radical and the square cancel out. This is considered simpler. Doesn't seem like it, but that's the answer. And that's what my Casio said. So some of you might catch on to a shortcut. I'm going to put another one, like different color here. 11 over radical 5. Well, okay. So I times by radical 5, radical 5. Whatever's on the bottom, because you don't like the bottom. So the top's 11 radical 5. And the bottom, what is this going to turn into? 25, which is 5. Anybody see a shortcut? Come on, shortcut? 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 What's going on? Where did this go? Didn't it just go to the top? That's a shortcut. Some people say, wait a minute, I already know what's going to happen. What if I put 8 over radical 17? And a lot of people say, you know what? This is all that's going to happen. This is going to go to the top. 8 times radical 17. And what's on the bottom? Just remove the radical. Ta-da! Same thing. Sometimes, though, you get a weird one. You can get a strange one, like this. Well, what do you mean strange? Okay, yeah, it's just going to go to the top, right? Yeah, I got the idea. 8 times radical 6 over 6. You're like, yay! You're not done. Can you reduce the fraction? Oh, yeah, 8 over 6. You can't work with this 6, because remember, this is a decimal. But that's a normal 8 and a normal 6. You can go, well, that's, I could cut these, they're even. Cut him into 4, cut him into 3. So your answer is 4 times the square root of 6 over 3. So your answer could look a lot different than the original. That's why you really, do need to kind of check it out. Okay, let's do some review. Can you figure these out? Let me get this off the screen. What do we got? Figure them out. Okay, pause the video, come back, and I'll tell you the answers. All right, welcome back. So I'm supposed to figure out this mystery side, and I'd like to put this question on the test. Well, why don't we do the yellow triangle first? Let's do this little guy. Some of you, have you ever memorized this one? When you have 3 and 4, this side is 5. 3, 4, 5, the most famous Pythagorean theorem. But yeah, we can do the Pythagorean theorem, or you could work it out. 3 squared plus 4 squared, 9 plus 16. A lot of people see they just start to memorize it. Oh yeah, that one works out perfectly. Okay, so we've got 3, 4, and 5. So this is 5. Now you can do the other triangle. See, we got a right angle again. 5 squared and 12 squared. 5 squared and 12 squared. And a couple people actually memorize this one too. This one actually comes out to be a perfect number. We call it a Pythagorean triple when it's a perfect. That's 169. The square root of 169 is 13. It came out perfect, no decimals. Try the next one. Oh, 5, this is 5. See the marks? They're the same. So if they're the same, shortcut. 5 radical 2. So then this piece over here is 5 radical 2. Because look at this, there's a tie again. What's the last one? Oh, this is weird. Okay, what did you times it by to get this when these are exactly the same? Remember, like, you took 5 and you times it by radical 2? Take that answer, 5 radical 2. What do you throw on the end of it when they're exactly the same? You just throw a radical 2 on it. Wait a minute, we can't leave the answer like that. Let's multiply this out. Let me use my paper here so I can draw a little better. Okay, so here's my paper. So we had 5 radical 2, and we need to throw radical 2 on it. So let's see. Radicals like to be with radicals. So 2 times 2, 2 times 2 is 4, right? What's the square root of 4? 2. In fact, wouldn't these cancel each other out? Isn't that radical 2 squared? So I have a 5. Radical 2 is radical 4. Square root of 4 is 2. I have a normal 5 and a normal 2. 10. 10 is that length. Okay, so this side is 10. Exactly 10. Yeah, those are kind of fun. Okay, let's give you another one. I'm going to skip some of these. How about this one? I put might be on test. Well, if we had more time, I don't know, put some there. Could you work your way all the way around to that? I'm going to pause it and let you think about it. All right, welcome back. I'm going to try to write these in on here. 1, 1. Okay, so in here, there's not much room. That would be radical 2. 1 times radical 2. Radical 2 times radical 2. Radical 2 times radical 2 is square root of 4, which is 2. So this piece here is 2. This is 2. This would be 2 times the square root of 2. So with this, times that by radical 2. So that's 2 radical 2 times radical 2, which is 2 times the square root of 4, which is 2 times 2 is 4. This is 4. 4 radical 2. What I did is I just kept multiplying by radical 2, by radical 2, by radical 2, and radical 2. Okay, a little more challenging. Some of you may get a little lost there, but just hang in there. This is one we won't get into. Remember we did the problems last chapter? You figure out all the sides. I'm not going to go into this, and there's also some tricky things here on congruent triangles that we had to skip. A 3-foot tall ramp covers 9 feet on the ground. How long is the ramp? Draw it. Okay, let's see. A 3-foot tall ramp covers 9 feet on the ground. Here's the ramp. Here you are, trying to get up the ramp. How long is the ramp? This must be a corner. Pythagorean theorem, right? 3 squared plus 9 squared. 9 plus 81 is 90, and the square root of 90. And of course you could change it to decimal, or you could go, what does 90 break into? 90. I got my list right here. My list. 9. 9 times 10, square root of 9 is 3. 3 times the square root of 10. I could also put in my calculator, and that's a little less than 10 overall. Another one. Joe walks 6 blocks south. Okay, go ahead and figure it out. Pause, come back with your answer. All right, welcome back. Joe goes 6 blocks south, then walks 8 blocks west is this way. Then he flies back home. on his pterodactyl? How far does he fly? And some people memorize this one. Do the Pythagorean theorem. This side is 10. How do I know that so quick? Well, I know 3, 4, 5. Aren't these numbers just doubled? 6, doubled, doubled, doubled. Oh, neat trick. The famous ladder problem. If you're going to do some college entrance test, the SAT, this is the question they love. They love ladders. Here's a ladder. It's scooted back from the house, not really realistic, 21 feet. The ladder's 35 feet long. Notice I have the hypotenuse. How high up could you go? How high up is the man standing? So let's do Pythagorean theorem. And I got the big piece, so let's go 35 squared, subtract 21 squared. And I definitely got to pull the calculator out to do this because the numbers are so big. 35 squared is that number minus 21 squared. And I get 784. So he's not 784 feet. Oh, square root. Square root of 784, 20. Hey, it's perfect, 28. Yeah, 28. Because this was actually a 3, 4, 5. It is? Times them by 7. 3 times 7, 21, 28, 35. Clever. Okay. There's another ladder question. I'm going to skip it. Here's a little joke. Somebody up in the building, fire, help. We need help over here. He's got a ladder. Where's Pythagoras when you need him? Somebody skipped math class. Some more ones that get kind of sneaky and tricky. How long is the zip line? Once again, you could do that guy squared and that guy squared and take the square root. I'm going to skip. Another bookcase. So these are problems we did in class. A TV is advertised as 50 inches. When they talk about the size of a TV, did you know they're telling you the hypotenuse? When it's 50 inches, they mean it's 50 inches diagonally. If the TV were 30 inches tall, how wide is it? So if you have like a 50-inch TV, if you're so lucky to have one that big at home, measure it. It's not 50 inches across, but it's 50 inches diagonally, the hypotenuse. And if I do the Pythagorean theorem backwards, 50 squared, because I got the hypotenuse, I got the big guy, minus 30 squared. Do your work here, 2,500 minus 900, 1,600. Square root of 1,600 is 40. Wait a minute, 3, 4, 5. Not always 3, 4, 5. I'm doing that on purpose to make it easy. And here's the super neat trick. Most people don't know this. It's not in any book, but you can go 3D. Imagine you had a closet and you wanted to put like a broom in there. Did you ever try to kind of wiggle it in kind of diagonally to try to get it to fit? What's the longest pipe that would fit in this box? I would demonstrate this in class with a 3D box. But what if these are the measurements? Well, you could go a squared plus b squared plus c squared is d squared. You could square all 3 of these, add them up, and then take the square root. So square all 3. You can go 3D with the Pythagorean theorem. They don't tell you that. Find it in a book. You won't. 64 plus 9 plus 25. Add that up in square root. That's the square root of, what do I got here? 34. I got 98. And the square root of 98. Wait, can you break that down? Yes, believe it or not, I got my list right here. 49 times 2. And the square root of 49, I'm going to go up top, is 7 times the square root of 2. I could also just use my calculator. And the square root of 98, 7 root 2. Decimal-wise, it's about 9.89. Yeah, because you knew it was going to be bigger than 8. Pretty cool. 3D Pythagorean theorem. And here's some last little reviews. I didn't show you all this. See what you can come up with. Okay, welcome back. So to do these problems, get my paper. Okay, so here's our answers. Okay, so the square root of radical 125, what goes into 25? So I would go, let's see, 125 is 25 times 5. 5 quarters is 125. Square root of 25 is 5. 5 root 5 is your first answer. The next one, number 2, something I hadn't talked about, but we would have if we were in class. Remember how we can add cookies? What if I said a cookie plus 2 cookies? Isn't that 3 cookies? How about x plus 2x? Isn't that 3x? Well, same here. I have a radical 5 and I have 2 more. That's 3, isn't it? 1 of these and 3 of these. Well, what about this? This is different. You can't combine like terms. You would break this into radical 5, whoops, into radical 4 times radical 5. 4 times 5. I know the square root of 4 is 2. 7 times 2 is 14 radical 5. Okay, so radical 4, radical 5. Square root of 4 is 2. I have 14 radical 5. 3 cookies plus 14 cookies is 17 cookies. Okay, can't really put that on our test right now. If we were in class, we would get more into that. Here's another one I wanted to show you, but I didn't teach it to you. Multiplying. Yes, you can multiply. Normal numbers multiply with normals. 4 times 5 is 20. Radicals like to multiply with radicals. So they're inside. 3 times 12 is 36. Oh, wait, I know that. That's 6. 20 times 6, final answer, 120. Okay, here's another one. Oh, we don't like the radical on the bottom. 6 radical 8 over 8. Okay, because how did I do that? I just times the top and bottom by radical 8. Oh, wait, I can reduce. Those are even, 3 and 4. 3 radical 8 over 4. You know what? You're still not done. What do you mean I'm not done? Radical 8. Oh my God, this is an advanced question. I remember radical 8 is 2 root 2 over 4. So now I have 3 times 2 is 6 over 4. Oh my God, I can reduce again. 3 radical 2 over 2. Well, that was crazy. That's not the only way to do it. You could have done this a lot of different ways, but this is your answer. Last one, much simpler. 11 radical 5 over 5. Oh, everybody's odd. We're done. Okay, there it is. I know I threw some advanced ones that I would expect you to do if we were in class. Too bad we're not there. But once again, in Math 2, you're going to do this as one of your first chapters in like September. All right, guys, tomorrow's a test. Have fun. Please don't use your Casios on the test. That's cheating. Try to figure it out by paper.